Hey everyone, welcome back to another video lesson. I'm hoping the first one went okay. You got your assignments in on time. And yeah, for the first video lesson, if you have any suggestions or feedback, I'd really appreciate hearing it. And anything you think I could do better, what's going well, what I could work on, it would really help me improve and get better at doing this kind of stuff. All right, so that day one lesson was all about the AC method. So that AC method that allowed us to factor quadratics, which look like ax squared plus bx plus c, right? It let us factor when this a value was greater than 1. So when that a value is greater than 1, what we saw is we could use the AC method to factor it. Right? And previously, before this AC method, we saw how to factor quadratics like x squared plus bx plus c, where the a value was equal to 1. Right? Then all we had to do was find two numbers that multiply to this, the c value, right, and add up to that, the b value, and then we were done. So when a was equal to 1, I guess we can just call that trinomial factoring. Alright, so I just wanted to do a very quick example of each. So hold on, let me pull up the question a lot of people struggled with on the first assignment. And give me 1 second to pull it up. I'm sorry, I don't have this prepared. Alright, so on assignment number 1, letter 2b, a lot of people messed that one up because it looked like 6x squared minus 24x minus 72. So people were looking right away and saying, oh man, this a value, that a value is a 6. That means I have to do AC method. But when in fact, like we've said many times, the first step when factoring is to always look for a GCF. So 6 is actually a GCF here. 6 goes into 24 and also goes into 72. So if you factor out the 6, you get x squared minus 4x minus 12. And really this is just an example of factoring a trinomial where that a value is 1, right? This guy here is 1. So we don't need AC method here. We can just factor normally by saying what two numbers multiply to negative 12 and add up to negative 4. And I believe those numbers are negative 6, right, and positive 2. And you bring down to 6, and that was it to factor that. So if you did do the AC method, it would work. It'd just be much harder. You have to do 6 times 72, and that's what a lot of people did. Find what multiplies to 6 times 72 and also adds to 24, which is crazy. And then once you did that, you still need to factor out a GCF at the end. So that was an example where you don't need AC method, whereas something like 4x squared plus 11x plus 6, this one has no GCF. So the a value is a 4 and we can't really pull it out. So this one you do need to do 4 times 6 and follow the AC method. So just a quick reminder that yes, we can still factor trinomials like this when the a value is equal to 1, but also more importantly, make sure you're always looking for that GCF. Alright? So number 1, down here, let's solve some more quadratic equations. So just something to practice. I'm just going to organize my notes a little. But again, when solving equations, I guess I can write out the steps over here. Don't forget, step 1, we want to get it in standard form and set it equal to 0. So get into standard form. and have the standard form equal 0. Right, step 2, we're going to factor. And now we have 4 methods of factoring. But still, first, and always first, is we're going to be looking for a GCF. Right, we got a difference of 2 perfect squares. We got just normal trinomial factoring. When a is equal to 1. And lastly, now we got the AC method. And we're using that when that leading coefficient, that a value, is bigger than 1. And after we factor, right, we're going to use the zero product property, and we're going to solve for x. So, number 1 here, I'm going to subtract the 121x from both sides, make that equal 0. And actually, it might be a good idea to actually pause the video now, try these problems on your own, see how you do. But I'm going to continue on now. Right, this is a really important skill. It's just solving different kinds of equations. We know how to solve all different kinds of equations, absolute value equations. But these quadratic equations, very important to know how to solve. So we get this crazy looking guys. They're a GCF here. 36 and 121. I don't think anything goes into both of them, but I do notice that both of these guys have an x. So I can factor out an x. And I get 36 x squared minus 121 equals 0. And by the way, these are harder problems, some of them at least, especially this first one I think is a little challenging. But these are all stuff that we've done and we've talked about. So, taking a look inside that parentheses, I got 36x squared and 121, and both of those are perfect squares, and it's a difference, it's a minus in between. Right? I know they're perfect squares because I can take the square root of them. 6 times 6 is 36. So, the square root of 36 is 6, the square root of x squared is x, and the square root of 121 is 11. So factoring like a dots, I'll have 6x plus 11 and 6x minus 11. Bring down this x, and there we go. Now it is fully factored. And only now that it's fully factored can I tee it off and get my solutions. So in this case, I'm doing x times 6x plus 11 times 6x minus 11. So I should have 3 solutions. You set each one of those factors equal to 0. And there we go. We get 6x here equals negative 11. X is negative 11/6. Over here we get 6x is equal to positive 11 once we add 11 to both sides, right? And x is 11/6. Alright, nothing new here. GCF into a dots into zero product property. So this one we can only do after yesterday, because once we set this one equal to 0, well, we didn't know how to factor this one before, but now we can do it, even though that a value here is a 4, because now we know AC method. So a times c, 4 times negative 15. AC is going to be 4 times negative 15, which is negative 60. I'm looking for 2 things that multiply to negative 60 and add up to my middle coefficient, that guy in front of the x, negative 11. So I'm going to save some time and just going to tell you the 2 numbers are 15 and 4. The 15's got to be negative to add up to negative 11 and multiply to negative 60. And using those 2 numbers, I'm going to break down that 11x into minus 15x and plus 4x. Alright, bring down to 4x squared and a minus 15 equals 0. And now we're going to factor out a GCF from the first 2 terms and the second 2 terms, factor by grouping. Right, exactly what we did yesterday. The only difference, we're doing the same kind of factoring, except this time it's equal to 0. So after we factor, we can get some solutions. Alright, so GCF of the first two is an x. We have 4x minus 15 left over. Alright, out of the second two, there is no GCF. Right, people have trouble when there's no GCF, but what you do when there's no GCF is you just pull out a 1 or a negative 1. In this case, it's going to be a positive 1 because if that's positive, you keep it positive here. So factoring out a 1, 1 times what is 4x minus 15? Well, it's going to be 4x minus 15. Right, now we're going to group, or factor out the GCF of 4x minus 15. They have that in common. That gets pulled out, and we have an x plus 1 left over. Right, now it's equal to 0, so we can tee it off and solve. 4x minus 15 equals 0, and x plus 1 equals 0. So 4x equals 15, divide by 4, x is 15/4, and also x could be negative 1. Alright. Alright, next one. This does not look anywhere close to 0 or anywhere close to standard form. So what I'm going to do is distribute first. And I get 40x squared minus 4x squared times negative x will be minus 4x cubed. And all of this is equal to 36x. Oh boy. Alright, so I want this to equal 0. So I'm going to try minusing 36x from both sides. That's x squared, that's an x cubed. So I got to just put this minus 36x to the side. Right, there's no like terms here. So 0 equals 40x squared minus 4x cubed minus 36x. And looking at these three terms, I notice they are not in standard form because the x cubed should come first, right? Standard form is in order of decreasing exponents. So my biggest exponent is x cubed, so that should come first. My next term is a positive 40x squared, so that's plus 40x squared. And the last term is going to be minus 36x. And now let's look for a GCF. So GCF, I notice they all have an x, so I can take out an x. And 4, 40, and 36, they're all divisible by 4, so I can also factor out a 4. So I'm going to factor out a negative 4 because I don't want my guy in front to be negative. Makes it a lot harder. So because the leading guy is negative 4x cubed, I'm going to factor out a negative 4. So factoring out a negative 4 from negative 4x cubed, I'm going to have x squared left. Right? You can think negative 4x times what gives me negative 4x cubed. Or you can divide negative 4x cubed by negative 4x to get x squared. Right? Here, 40 divided by negative 4, that's going to be negative 10. X squared divided by an x, that gives me 1x. 1x cancels out. Right? And then negative 4x times what gives me negative 36x, or negative 36x divided by negative 4x. That's going to be positive 9. And again, all of that's equal to 0. I got to keep factoring. Inside those parentheses, that factors to x minus 9 times x minus 1. And teeing this off now that's fully factored, I can say negative 4 times x equals 0, x minus 9 equals 0, x minus 1 equals 0. Right, so I'm using the zero product property, setting each factor equal to 0, and that's going to give me three solutions here, 0, 9, and 1. Right, on this first one, sometimes people have a little trouble getting x equals 0. All we're doing is you can divide both sides by negative 4. Or even easier, just think about it. Negative 4 times what is 0? Yeah, negative 4 times 0 is 0. So we get these three solutions. That was definitely a challenging problem. All right, next. This is something a little more typical. If you distribute the x here, we get 2x squared plus x equals 10. We want to make this 0, so let's subtract 10 from both sides. And again, I can't factor out this 2. That's not a GCF. So what method do I need to use here? That is right. At least that's right if you said AC method. So we got to use AC method. A times C is negative 20. Boom. So what multiplies to negative 20 and adds to our middle coefficient here, which is a 1. So that's going to be positive 5 and negative 4. So splitting this up, it becomes 2x squared. That 1x becomes plus 5x minus 4x, which of course is 1x. We're not changing the problem. We're just doing this so we can factor it. And now factor by grouping, GCF of the first two. 2 and 5 don't have anything in common, but x squared and x, I can take out one of these x's. I get 2x plus 5. Over here, that middle guy, that's negative. So what I have to factor out is something negative. And 4 and 10 have a 2 in common. So pulling out a negative 2, I need to multiply this, or divide this by negative 2, and I get positive 2x. So negative 2 times 2x is negative 4x, and negative 2 times positive 5 is negative 10. And again, these parentheses better be the same. If they're different, go back and check your work, because something must have happened. All right, so we get 2x plus 5 times x minus 2 equals 0. Tee it off. 2x plus 5 equals 0. 2x equals negative 5. X is negative 5 halves. And over here, x equals 2. So, solving quadratic equations. We've done this before. These problems are definitely a little more challenging, but same steps as before. We're going to get it in standard form, make it equal 0, and the only thing we've added is this AC method, right? That let us do these two problems that we were not able to do before. So, yeah, I'm hoping that you try these problems. These were some tough ones, but doable, and a really good summary of solving quadratic equations that we've looked at so far. Alright, so today, from the first assignment, that last question was not too hot, the graphing one. So again, let's talk about how we can graph a quadratic equation, like this one. So when we want to graph a quadratic, the first step, pretty much all the time, is going to be finding the zeros. And we know another word for zeros are x-intercepts. So the way we find x-intercepts or zeros is we make our function equal 0. Right? We make y equal 0. Make y equals 0, or f of x, our function equals 0. Same thing. Right, so I'm going to do that here. And making f of x 0, we get 0 equals 2x squared plus 3x minus 20. Alright, so this is one of those problems where we need AC method because I can't factor out this 2. So 2 times negative 20 is negative 40. What multiplies to negative 40 and adds to positive 3 here? That's going to be 8 and negative 5. So we get 2x squared plus 8x minus 5x minus 20. Alright, we have 4 terms. Why did we want to get 4 terms? It's so we could have done factored by grouping. Factor out a 2x here, x plus 4. Right, factor out a negative 5 here, x plus 4. And x plus 4 is a GCF that comes out. 2x minus 5 is on the outside. That will be on the other parentheses. That's equal to 0. And so when we tee this off, we're going to have zeros at x plus 4 equals 0, or at x equals negative 4, and at 2x minus 5 equals 0, or at 2x equals 5, which makes x equal to 5 halves. Alright. Let me just organize this a little. So when I say make a sketch by plotting the x-intercepts, well, we make a sketch, make our x and y axes. So for a sketch, you don't need to really scale it, but they should be kind of in the right place. So if I make negative 4 here, for example, 5 over 2, which as a decimal, by the way, is 2.5, right? That's going to be, I don't know, somewhere over here. You should make it semi-accurate. So we know our 2 zeros are here and there. Now all we have to do is find the vertex. So the vertex is going to be directly in between negative 4 and 2.5. So I don't know, somewhere over here. But you don't want to guess. So what we got to do is actually figure out what is exactly halfway between negative 4 and 2.5. So to do that, we can take the average of those two numbers. So if I average my 2 zeros, negative 4 plus 2.5, and divide it by 2, what I get is negative 1.5 divided by 2, which is negative 0.75. So that is where the axis of symmetry is. This guy here will be x equals negative 0.75. And so we know our vertex is on this point. So all we have to do now is plug in negative 0.75 into our function, this guy. So let me actually copy and paste this. Copy. Paste image. And this is definitely, again, this is a little more challenging than normal. Alright, and that's because we're getting some decimal values. But we're going to plug in a negative 0.75 into our function. And the reason we're doing that is, again, we know our vertex, it's somewhere on this axis of symmetry, whether there or there or there. Right? We know the x value of our vertex is negative 0.75. What we don't know is the y value. So to get the y value, let's just plug it into our equation. Right? We plug in the x value of negative 0.75. So doing that, we get 2 times negative 0.75 squared plus 3 times negative 0.75 minus 20. And at this point, I would just type the entire thing into the calculator and see what we get. So that is what I'm doing right now. And doing that, it looks like we're going to have a value of negative 21.125. Alright, be careful typing it into your calculator. Make sure you have the parentheses where you need them. But that's what you should get. Alright. So that vertex, negative 0.75, comma, negative 21.125. 125. So when it says sketch, this is what I need on the sketch. I need the zeros and this vertex. And connecting the dots. Bam, that is what the function is going to look like. Alright, so that is a sketch of f of x. Alright, so let's do this one more time. And this one looks even a little more challenging, but it's going to be the same steps. We're going to find the roots. This time we're going to graph it accurately. I actually give you some axes here. And so let's try this guy. So a parabola is given by the equation f of x is negative 4x squared plus 24x minus 27. And first thing I notice, or first thing I'm going to try is to take out a GCF. So while 4 goes into negative 4 and 24, 4 doesn't go into 27. And I also can't take out a 2 because that's not even. So I'm thinking there's no GCF here to take out. So before I try AC method though, something I really don't like is that negative sign. So what I'm going to do is I'm going to factor out that negative before I do anything. So to factor out a negative, I'm going to factor out a negative 1. So if I factor out a negative 1, the 4x squared, the negative 4x squared becomes positive 4x squared. Right? The positive 24x will become negative 24x, and that negative 27 becomes plus 27. And now that that negative is out of my equation, or factored out, all I have to worry about is doing the AC method to factor this trinomial. Right, so 4 times 27, that is 108. So what multiplies to 108 and adds to negative 24? That is a good question, because I got to think about it. But hopefully, using our calculator, we can figure out what that is. So this is definitely a one where you might want to use the trick of graphing y equals 108 divided by x and looking at the table. Alright, doing that, I think we will see 1 times 108, 2 times 54, 3 times, using a calculator too, 3 times 36, 108 divided by 4 is 27. 6 go in. Yes. 6 and 18. I think that is going to be it, because that can make 24. But we want negative 24. So I think both of these guys need to be negative to make negative 24. Alright, so now continuing on with AC method. I'm going to split that negative 24x into negative 6x and negative 18x. I'm going to bring down to 4x squared. I'm going to bring down to positive 27. And again, this is all in parentheses times negative 1. Alright, now we do factor by grouping. Boom, boom. GCF of the first two, 4 and 6, have a 2 in common, x squared and x. I can take out one of those x's. That's going to be 2x minus 3. GCF of 18 and 27 is a 9. That's a negative 18x, so I want to take out a negative with it. Always the same sign there. And I'm going to have a 2x. And then negative 3 times negative 9 gives us positive 27. So again, these should always be the same, and they are the same. So we're happy. So this factors to 2x minus 9 times 2x minus 3. And lastly, do not forget about that -1 in front. Alright, so f of x is equal to this, is equal to that, is equal to this. And again, all of this was to find the roots. So, how do we find the roots again? Well, we find the roots by making it equal 0 and factoring. So I already did the factoring part. What I should have done earlier is to make this equal 0. Alright, so now that we know it's equal to 0, I can tee this off. That -1 doesn't give me any solutions because -1 doesn't equal 0, so you don't worry about that. But 2x minus 9 could equal 0. That's going to equal 0 when 2x is equal to 9, or when x is equal to 9 over 2. Alright, 2x minus 3 could equal 0. That's equal to 0 when 2x is equal to 3, and so x is equal to 3/2. So plotting those two x-intercepts, our roots, 9 over 2 is equal to 4.5. So I'm going to plot one of my zeros over there. Another 0 is at 3 over 2, which is 1.5. So I'm going to plot another 0 right there at 1.5. So what is the axis of symmetry? That is going to be directly in between 4.5 and 1.5, between my two zeros. So again, if you're not sure what's in between 4.5 and 1.5, we take the average of those two zeros. So 4.5 plus 1.5 divided by 2 is 6 over 2 is 3. So the axis of symmetry is x equals 3. Alright, drawing in that vertical line. Yes, we see it is directly in between our two zeros. And use the axis of symmetry now to find the coordinates of the vertex. So I'm going to plug in a 3 into my function here to see where the vertex is. It's 3 comma what? Alright, so let's paste that in. So f of 3 would equal -4 times 3 squared plus 24 times 3 minus 27. Alright, so just follow order of operations and clean this up, or you can type it straight into your calculator. But this one's not so bad. 3 squared is 9. 9 times -4 is -36. Plus 72 minus 27. So working this out, what is that equal to? 36 minus 27. I think this is equal to -9. Alright, so when x is 3, the function is equal to -9. In other words, I have the point 3 comma -9. Right? Input of 3. My x value is 3. The output, the y value is -9. So my vertex is right here at 3 comma -9. Oh, I'm sorry. At +9. Right, 72 is bigger, so sorry, just did a calculation error there. That's going to be at +9. So, aha! The vertex is actually above the zeros, so I knew I made a mistake when I wrote -9 because if we look at our function, what's our leading coefficient? It's negative. So when that leading guy is negative, we know it's going to be a frowny face parabola, and we're going to have a maximum. So that's why the vertex is up there. So when we sketch it, when we connect these dots, right, and you might want to use a calculator to get other points, but our parabola is going to look something like this. Beautiful. All right, and that's the graph of f of x. So these problems were definitely more challenging, but it's just like we've done before, right? We found the zeros by setting our function equal to 0, right? And then factoring it out and getting the x-intercepts or the zeros. Once we have our zeros, what we do is we find a point in between the two zeros by taking the average of them, or sometimes you can do it by counting. That's going to be our axis of symmetry. Then we know our vertex is on the axis of symmetry, so what we do is we take that axis of symmetry value and we plug it into our function for x to get the y value. That will give us the x comma y coordinates of our vertex. Right, so we did the same thing twice with two pretty challenging problems, but that is how you can graph a parabola in standard form. Right, I know there's one more question on the bottom here, but we'll save that for next time. All right, that's when it gets interesting. That's when we start doing parabolas or quadratic equations that represent stuff in real life. So look forward to that. But that's it for today. All right, you might want to watch this video a couple of times. Put it on 0.5 speed or maybe 1.5 speed if you feel you really got it. But rewatch it as you need to pick up all the details, and please try the posted assignment. All right, I'll see you guys next time, and have a nice day. Bye-bye.